Now that we have completed all that we needed to know about Ansible, we are ready to move to the next item on our course outline, and we are going to work with Docker and Docker Compose quite extensively in the next 2-3 classes until the final exam. So today is going to be a sort of a very general introduction around Docker. You probably have a lot of experience and knowledge with Docker. So I'm not going to go too much in depth about what Docker is, how it works, and what it is compared to a regular operating system. But basically, it's a containerization program that allows us to run containers. Containers being small, isolated pieces of software that can be run without requiring a full-blown operating system, yet retaining all the good stuff that we can do in a Linux/POSIX environment. So that's the premise with Docker. And in order for you to use it, you need to have it installed and set up on your computer. We are going to use Docker, and we're going to use Docker Compose. So make sure that it is installed. I'm using a virtual machine myself that runs Docker on it because I find it's easier to manage with my Windows settings. It's up to you to make it work. You can also use Docker desktop if you'd like. So once you have set up Docker in the way that is the best way for you, you can access it in the command line with the Docker command. So the first command that I'm running here is docker ps, which is the same as ps in Linux, and that will show you all the Docker containers running on your system. And at the moment, there is none of them. So the concept of Docker is that containers are based on images. So pretty much like AMIs or virtual machine images that we've used on Amazon. Docker images are like pre-made images of things that you can run in a Docker container. There is a huge repository of images that are pre-existing and that you can use and reuse. They are made by the community and sometimes by very prominent names in the community. So you have a Ubuntu image, you have a Red Hat image, but also you have application images, and this is what's most interesting for Docker. You have Nginx images, you have MySQL images, etc., etc. Once again, the concept is that the container is the service. So when you want to run MySQL in a Docker container, you're not going to run Linux and install MySQL in it. You're just going to run a single container that just runs MySQL. So the way it works is that with Docker, you can run images. And that's the first thing that we're going to look at. And the images that you are going to run are either available locally or available on the internet in a location called the Docker Hub. So the Docker Hub is a huge repository of Docker images that the community can contribute to. You can also upload your own images on the Docker Hub. And the image that we are going to use in the Docker Hub just to test our Docker setup is called Hello World. So you can Docker run Hello World. And what Docker is going to do is that first it's going to check for that image locally on our computer. And because that's the first time I'm running that command, this image does not exist on my laptop. So because it does not exist locally, Docker is going to pull it from the Docker Hub, which is what you can see here. And then the image is downloaded, and then the image is being run. And this image is basically just saying hello from Docker and whatnot. And if it shows up, it means that everything went fine. Now, if you would like to know a little bit better how this image works, you can have a look at the Docker Hub website, which is on hub.docker.com. I'm going to change my screen sharing here. So this is the Docker Hub, hub.docker.com. This is where you can find all pre-made images by the community. And here you have some information about what this image does. So you have a couple of tags, you have some reference and an example output of what the image does. This image doesn't do anything at all. It just runs a message and it shows that your Docker has been run. Now, if you try to run it again, because the image has been downloaded locally on your computer, Docker doesn't need to download it again. It will just reuse the image that was downloaded. If for some reason we would like to update or re-download the image from the Docker Hub, we can use the Docker pull command, and that is going to get the latest image for the Hello World container onto our laptop. So that's an example with the Hello World container. You have hundreds or thousands of images that you can run. Working with containers is a bit like working with Legos, hence the logo of Docker. But basically, you are going to set up small software pieces and bricks together, each one of them being a Docker container. So now back into my terminal. Hello World is interesting, but it would be more useful if we can run actual applications that we are going to need. So Nginx is a very good example. There is a Docker image for Nginx, which is available. So what we're going to do here is just Docker run Nginx. Obviously, I'm not just using Nginx out of my hat, because I looked first in the Docker Hub how the Nginx Docker image was built and how it works. So what's interesting here is that when we Docker run Nginx, it's a much larger image than the Hello World image. So it will download, it will take longer to download. And also there is a very important concept with Docker in the concept of file system layers. So you can see here that I have different pull operations. Each operation is going to build upon the previous layer. And that's a very important concept for Docker. So when you are going to build your own images, you are going to reuse an existing image and add on top of it. Now, this is the output of our container. And what's going on here is that Nginx is running in the container and it's listening to requests on the container. So what that means, contrary to the Hello World container, which was just running a command and then exiting, this Nginx container is running a service. So basically, we just ran Nginx, and now Nginx is waiting in the container to serve requests. This was the output of my Nginx container. Now, if you open a new terminal on your Docker machine and you run the Docker PS again, now you will see that my Nginx container is actually up and running. So this is why we have one container in the list. We have an ID for that container, the name of the image that it's running, when it was created, and also on which ports does this container listen. So here we can see that it's listening on port 80, which is the typical port for an HTTP service. Our container also has a name. The interesting thing about Docker is that if you don't give a name to your container, Docker will generate one for you. So that's where this elegant Ardingly thing is coming from. It's just a random generated name, and obviously for administration purposes, you should set your name explicitly to make it easier to understand what's going on in your infrastructure. So now our Nginx container is running, but the problem is that we cannot really access that container at the moment because it's only listening on the internal Docker network. So I'm going to fix that. I'm going to stop the execution of the container by pressing Ctrl+C. And now you can see that my container is stopped. Well, it's stopping and actually stopped. And now I can run this command again. We can double check now that we don't have any running containers in our Docker PS. And now I'm going to run Nginx container using additional options. So what I did here is that I added the P argument, which stands for port forwarding, and that's going to set up a port forwarding between my host and my Nginx container. All right, the image is already available locally on my system, so it comes up real quick. And now you can see that, well, first of all, the name of my container was changed. Containers are very much like non-persistent, so you can create and delete them as you please without any side effects. And the most important thing here is that there is port forwarding setup. So you can see here that on my Docker host, if I try to access port 8000, then there will be a port forwarding that will forward this traffic to port 80 inside my container, which means that if, and I'm going to change my screen sharing, if you access port 8000 on localhost on your computer, which is running Docker, then you will have access to that Nginx container, which is listening on port 80. So that's the basics of running containers, forwarding ports to get access to them, and using Docker as a containerization platform. Now, this is all very basic. What we want to do is to be able to build our own images. So let's say, for instance, that instead of running this Nginx container, which doesn't have the interesting things that I'm looking for, I would create my own Nginx container with my own customized settings. That would be quite interesting. So that's what we're going to do. So I'm going to press Control-C. That's going to make Nginx exit. And now I'm going to create a Docker file. Dockerfile is a file that allows you to define how a Docker image should be built and what this image should contain and how it should run. We're going to create a new file here, a new Docker file. And the first thing that we are going to write in our Docker file is the image that this container is going to be based on. So we want to build an image that is based on Nginx. So I'm going to use from Nginx. The name of the container that you want to use here is the same as the name of the container that is available on the Docker Hub. So sometimes you may see things like Nginx/Nginx or team/Nginx thread, something like that. So there are situations where you need to give a fully qualified image name. Nginx being a very popular Docker image, you can just use from Nginx. So that tells Docker that when you build that image, you want to base your new image on the Nginx image that is available. So I'm just going to use that. And now, because this folder contains a Docker file, I'm going to use a new Docker command called docker build. And this command allows you to build an image from a Docker file. So here, the Docker build process works with a context. So you have to provide a directory which contains a Docker file. Here, this is the current folder, dot. So we can just use docker build dot. All right. So we've just built a new image based on the Nginx image that we had already existing. Now, this is not really interesting because we just built that image based on Nginx and we didn't do anything with it. So it's basically the same as the Nginx image. And also, we didn't give it any specific names or anything like that. So we are going to fix that. If you look at the options, you can see that there is an option to give it a tag with the -t option. So that's what we're going to use to rebuild our image and give it a tag. So we are going to give it a tag as local, let's say, and we'll use my Nginx for the name. Now we can run the build again. And now you can see that this image is now available locally with this tag, local my Nginx. You may want to look at the local images available on your system by using Docker images. Okay, Docker images, and this shows all the images that you have on your system. So this is the Nginx image that we pulled from the Docker Hub, and this is the local Nginx image that we created from our own Dockerfile. And you can see here that it has been tagged with the my Nginx tag. All right. Now, if you look at the Docker Hub for Nginx, which is this one here, somewhere in the documentation it says that all right, that's the location that is by default configured in Nginx to serve static content in that container. So /usr/share/nginx/html. We could have a look at the Nginx configuration file, but because we have a lot of information here on that page, we can probably just work with that. Very interesting thing is that you can look at the Docker file for that image, the Nginx image, yourself, and then you can understand better what it does and how it's been built. So you can see that there is a couple of shell instructions here that are pretty complex, but basically it's the same kind of syntax as what we've used using from, etc., etc. So we're going to go back here, and what we're going to do is that we are going to create a Docker file that creates an image which already has some HTML content pre-existing in our HTML folder. So the example I'm going to use here expects an HTML page to exist on your laptop. I'm just going to create it real quick. Hello. That should do the trick, I think. Okay, so now I have this page.html, which is the equivalent of my static website that I want to set up in my Docker image, so that I can just run my custom image and my static website will already be available in my Docker container. So we're going to go back to the Docker file, and this time, because we want to have this page.html available in the Nginx folder, we are going to copy page.html into /usr/share/nginx/html. So all these instructions here that you see in dark orange, you need to know them, and they are available on the Docker website and Docker reference. From is the source of the image that you are going to build your image on. Copy is exactly the same as Ansible. It allows you to copy a file from your local computer, your Docker host, to your Docker container. So here I'm going to copy page.html into the Docker container. I need to rebuild my image because if I run my image again without making any changes, it will be using the old build that I made a couple of minutes ago. So I recreated my image. I actually forgot to use a tag, so I'm going to do it again. Okay, and now I can look at my images and I can see that my Nginx image was created 14 seconds ago, which is, well, right now. So now I should be able to run using -t again, a local version of my Nginx container. So I ran the same command with docker run, but this time, instead of giving it the Nginx location, I'm using the tag, and I ask Docker to run a container running the local Nginx image that I just built. And because you're paying attention here, I forgot to do something. I forgot to forward my ports, meaning that I had no access to my Dockerized Nginx because my ports were not forwarded. I'm going to run it again, this time forwarding the ports. And what is going on? Oh, yeah. So now if you refresh the page, sorry, I was here. If you refresh the page for your Nginx, you will still get the same info, because this is the index.html, and we copied the page as the page.html. So we need to change the URL to make sure that we're accessing the page that we created earlier. Probably that's kind of an oversight, and I can change the Docker image. I'm going to stop my container with Ctrl+C, and I'm going to edit my Dockerfile. And here, I'm going to change its name and call it index.html. Let's build that thing again. Build. All right. Okay, so now it's been built. And we want to run it with the right tag. Okay, so that's probably run -p 8080 -t local my Nginx, and that should be it. Okay, and now if you refresh in your browser, you should see the actual example page that you have just created. So now every time you're going to run this Nginx container, you're going to be able to see this HTML page. That's just one example of what you can do with. So I just found on the internet this HTML that is seemingly Bootstrap template. I think it's very old because it's using Bootstrap 3. I'm not sure it's going to work, but we'll try to make it work. So we are going to create an image that downloads this HTML file and sets it as the static content for our Nginx container. So I'm going to edit my Dockerfile again. Let's keep my page.html here. And now I'm going to run a command. So I'm going to use, I think I'm going to use wget. This is the URL that I want to access. And here I'm going to save that output into an index.html file in the Nginx static folder. So let's build this again. Okay, so I made a mistake here. It looks like my container does not have wget, but maybe it does have curl. So I'm not that familiar with curl, so I'm going to look at the instructions on how to use it. Curl, I think it's small o. Okay, small o instead of the big O for wget. So I'm going to change this wget into curl and this big O into small o. I need to run it again. So the good thing is that when you run your build, you'll see the actual output of your command. Here you can see that you have this seemingly interactive output from curl, which is not really useful for us. So I think I'm going to remove that output and I'm going to use my QQ for quiet and S for silent. And now I have a nice clean output for my Docker build. So now this image should have this HTML that I downloaded from the internet. So I'm going to run it. All right. And I'm going to look at it in my browser. And not surprisingly, I have a very nice HTML page that was loaded that uses the Bootstrap template. This is not functional, but it could be our static website that comes from our GitHub repository, for instance. So very important, from, which allows you to specify the image that your image will be built on. Copy, which can copy files from your local host to the Docker container, and then run, which can run any command in the container context during the build stage. So any command that you want to run, and that was an example here with wget, needs to be available in your Docker container. You cannot run wget if wget is not available in your container. So sometimes you will have to install a couple of additional software and binaries in your containers in order to make them do what you want them to do. All right. Now this is all nice and good, but the problem is that this is a very one-off kind of solution. It allows you to run isolated containers and have them do what you want them to do, like for instance, run Nginx here. But it's very clunky. If I wanted to run, as in our example, a front-end / static service on Nginx plus a middleware application server with Python plus a MySQL database, then we would need to have 3 Docker containers. Actually, we need to have 3 Docker containers because each Docker container should only do one and one only service. So each of them needs to be in separate Docker containers. It would be very clunky to manage them with the Docker command. So we are going to use an orchestration tool, which is docker-compose. You probably have seen Kubernetes in other classes. It's a different kind of orchestration tool, but the concept is the same. You are going to create and build all your Docker images, and then you're going to use the orchestration tool of your choice to make them work together. This is what we're going to do, and now you're going to have to make sure that docker-compose is installed on your computer. It's the case for me here, and I have docker-compose installed on my laptop, which means that I can start using docker-compose. So this is what we're going to do now. We're going to look at how we can use docker-compose to make different kind of containers work together. So the first thing when you work with docker-compose is to create a docker-compose file. This Docker Compose is using the YAML syntax. So you will be familiar with it because it's pretty much the same as an Ansible playbook, except that it has more options. So we're going just to create that Docker Compose file, and then we're going to stop filling it up. And I was not sharing the right screen. So that's the Docker Compose version that I have. And I'm going to stop writing my Docker Compose file right now. So with Docker Compose, you write a YAML file. And this YAML file should contain the version of the Docker Compose that you're using. Nowadays, it's pretty safe to use version 3. So I'm going to use version 3. And then your Docker Compose file will define a number of services, and each of these service is going to be one set of Docker containers running a given Docker image. So let's say we would like to run a web service. We're going to use the web name here, and we're going to use the Nginx image. And that should be the minimum viable compose file that we can use to run an Nginx container in using Docker Compose. Let's do that. So we can use Docker Compose now, and we can start our infrastructure by using Docker Compose up. Now you see that this container, this service web that we have created, is up and running on our machine, and we see the same kind of output as what we saw when we run the Docker container manually. So the same situation happens. So this is another terminal. So with Docker Compose, you can also run Docker Compose PS, and that gives you information about the containers that are running in your Compose environment. Each Compose environment is separate. So here I'm looking at the containers run with Docker Compose in that very folder that I am in. If I change or move to a different folder, Docker Compose will show me the containers that are running in that other folder. So at the moment, I just have one. You can see here that it's running the Nginx image, and that this container is actually up and running, and it exposes the port 80, which is the web port. And that's the name that was given to our container by Docker Compose. So this is something that was automatically created, but now you can see that this actually makes way more sense, because teamg here is the name of the folder that I am in, teamg. And web is the name of the service that I declared in my Docker Compose. So this is why my container here is called teamg for the folder, underscore web because that's the name of my service, underscore 1 because that's the first container for that service that was run. So this is all good. Now we can change that, and we can make sure that we do the same as what was done with Docker by forwarding a port on our Docker host to our Docker container running the Nginx service. Is that the, I'm going to change the spaces here because there are too many of them. Okay. So now with this Docker Compose definition, we can also specify which ports should be forwarded when running that Docker container. So the port forwarding comes as a list, and it contains all the ports that you want to forward. The first item is going to be the port on your Docker host. Here I'm going to use 8000. And 80, the second element, is the port inside your Docker container. So because we are redirecting traffic onto Nginx, which listens on port 80, we're going to use 8000:80. Save that file, and we can Docker Compose up again. So you can see that now our container is being recreated because some changes have happened to it. We changed the port forwarding. So Docker Compose has to recreate the container. And once again, the container is up and running. Now, if you run Docker Compose PS, now you see that this container is running, but you do have more information about the port forwarding settings that are set up. So now if you load this page in your browser, you should see the default Nginx page for your container, because we are using Nginx, the default image, and we are not using our own custom image that we created earlier. So we're going to do that now, and we're going to make Docker Compose build the Docker image that we have defined in our Dockerfile. So here, instead of using image, now we are going to specify the fact that we want to build a specific image. And once again, we are going to tell Docker that we want to build the image in the current folder, which is dot, because we are in the folder where we want to build. Now the web image, the web container is not going to run the Nginx image. What Docker Compose is going to do is that it's going to build the image first, and then it's going to run a Docker container based on that image. So the two steps are going to be combined into a single step. I can save that file. And I can do Docker Compose up, and you have interesting information here in the terminal. You see the build stage happening again with all the commands that we have created in our Dockerfile. And then we have built a new image. You don't have to worry about the tags. Docker Compose is going to tag them automatically itself. So here, for instance, use the teamg_web name, and the tag that was given was the latest tag. Now that this image has been built, so here you have a warning saying that Docker did not have an image for that service, so it built a new one. Then your container is run using this image you've just created. The problem here is that you don't really get access back to your terminal, and if you lose that connection, or if you make a mistake like pressing Ctrl+C, this is going to kill your service, and it's not going to be available anymore. So there is an option in Docker Compose by using -d for detach, and if you run Docker Compose up with -d, now it will instantiate your container, make it run, and it will keep running in the background. So now you can have a look at your web page in your web browser, and you will see that you did get your Bootstrap template, which is the one that you built in your Docker image. And this is all managed by your Docker Compose setup here. So now that this container is running, you can do a lot of different things. There are situations where you may want to inspect what's going on in your container, and you may want to just drop into a shell inside the container and inspect your files, your binaries, your permissions, and whatnot. So here, it's very easy to do with Docker Compose. You can use Docker Compose exec web bash, and that is going to run the bash command inside the web compose container. So now I'm inside the container. I am root. And if I browse to my Nginx folder, I will see all the files that I have created in my Dockerfile. So this is the page.html, and this is the index.html that was downloaded from the internet. So this is sometimes useful when you want to have a look at what's going on inside your container by running exec and the name of the container plus the name of the command that you would like to run. This is also something that you can do when you would like to check your Nginx configuration, for instance, you can run Nginx -t, and then you will, inside the container, run the configuration check for Nginx, and you will make sure that your configuration file is actually fine. Something that you may have done a lot in other classes that you should not do in this course is to use bind mounts for your Docker containers. Using bind mounts is a convenience that allows you to share files between your Docker host and your Docker containers, but it's not scalable, and it's not something that you should use in production because it introduces a very strong dependency between the containers and the host that they are running on. If you want to run the same containers on a different host and you don't have the same bind mounts or the same files available in your bind mounts, then the operation of your container may change, or it may not work as you expect it to work. So it's very convenient when using Docker as a development platform, but in production, this is usually a big no-no, and you should try to avoid that as much as you can. For all the labs and all the assignments, including the final exam that we're going to do, you should never, ever use a bind mount, because that's going to be a huge problem for you later on. So never use bind mounts for this class, because that will basically break most of the things that you want to work. Remember that Docker containers, they are transient. They are not made to be persistent. So if you need any kind of persistence, you should set that process up using an additional container and using shared volumes or something like that, but you should not use bind mounts for your volumes. All right. So now that we have this Docker Compose environment working with our own custom image for Nginx, we are going to build more things. Let's say that I would like to run MySQL. I'm going to use a MySQL server Docker image that I can find somewhere. But what I'm going to do here is move on to the Docker Hub and just go and search for MySQL. So we do have MySQL here, and we have MariaDB, which is the open source version of MySQL without the licensing issues. It's completely compatible with MySQL, so I'd rather use that for licensing purposes. So here you will see a lot of information about what you should use. There are different kind of tags that you may want to use for your MySQL service or your MariaDB service. If you're using latest, which is the default, that's the image that you're going to get, which is probably good. Most importantly, you will see that there are different ways of running that image. And most importantly, and this is something we're going to see in a few minutes, there are options and parameters that you can use to configure the way your Docker image is actually working. So basically, the image that we want to use is called MariaDB. So I'm going to switch back to my terminal. And I'm going to see that, okay. And I'm going to add a new service to my Docker Compose, and I'm going to add the MariaDB image to my infrastructure. This image, well, let's make it run. So I'm going to run up -d again, and Docker Compose is going to look at my Docker file, my Docker Compose file. It will sort of make a difference between what's already there and what's not there, and it will download whatever is missing and add it to my environment. So here I didn't have the MariaDB image available in my system. So now Docker Compose is downloading that from the Docker Hub. And very soon, we should be able to see the final environment up and running. So everything seems to be fine. I can look at my Docker Compose now, and you see that there are 2 Docker containers being active. One is the Nginx container that we have seen earlier, and the other one is the database container, which unfortunately doesn't seem to work because it says exit 1, and it should say up if the container was actually working. So there is something wrong going on here. So we are going to look at the logs and see what happens. So if you can just run docker compose logs, this is going to give you all the logs for all the containers on your compose environment. So there's probably going to be a lot of information. There is a lot of information here. And this is all about the web stuff. We're probably more interested into the DB stuff. So I'm going to go and look at the database logs by using DB. And here you can see why this image was not working. Basically, it says, well, whatever, database is uninitialized and the password option is not specified. We need to specify one of the following options in order to make it work. So what's happening here is that the MariaDB image is quite advanced image that takes configuration by using environment variables. So these variables allow you to set the root password for your MySQL service, or you can actually decide to leave it empty, or you can decide to create a random root password for your database. So this is something that you need to specify in the configuration of your Docker container. When you start it, you need to set one of these environment variables in order for the image to properly work. This is something that you can see in the documentation of the Docker image for MariaDB. It says here environment variables, and it explains how the variables work, and they explain also which setting you should use and where you should use it. So here we need to at least define one of these. So the easiest one to define is to make sure that MariaDB starts with a random root password, which is going to be automatically generated at the first run. So that's something we are going to add to our Docker Compose file in the environment section. And in this section, we're going to have a, sorry, I need to switch my screen. In this section, we are going to have basically a key value pair, like dictionary-like set of options that you can set in your Docker Compose file. I'm just copy pasting things. And here I'm going to say 1. This just needs to be set to something that is not empty. So in my case, I'm going to set it to 1, which means that this is not going to be empty. It's not going to be null, which means that Docker is going to generate a random root password for me the first time I'm going to run my containers. We made changes to the Docker Compose, so it's actually recreating the database. If you look at what's happening, you can see that the database container is now up and running. And you can look at the logs, and you can see that the database service has been initialized. And then a lot of initialization steps have been performed on the container for us. And you see here that the container image has generated a random root password for us, which is this one. So this is the root password for our MySQL instance. We could have set it to something we actually wanted, but using a random password increases the security of our container, because every time you are going to instantiate a new container, it's going to generate a new random root password, which minimizes the risks of reusing passwords and opening security breaches. That's pretty good. Now, there are more options that we can use in our Docker image, and you can look at the web page for that. But one of them is Maria or MySQL database, and that allows you to create a MySQL database directly from the initialization of the container. So here I'm going to use MySQL database, and I'm going to use video. You can also use a MySQL user, which will automatically create a user that will have access to this database that was created just above. And you can also provide a password for that user, which I'm going to use very secret. So now I made changes to my end variables in my Dockerfile. So if I run Docker Compose up again, then it's going to recreate my Docker container for the database. If you look at the log file, you will see somewhere that the MySQL user and database have been created. And now what we can do is try to access our database from inside the container. So I could run bash, and then I would be given a shell on my database container, and I could use MySQL -u. What was the name of the user? So I should be able to connect with example with the password very secret. MySQL -u example -p very secret. That didn't work. Okay. So I made a mistake here, and the thing is that, as I was saying earlier, there are volumes that can be defined in Docker containers, and these volumes can persist across restarts of your containers. The MySQL image is one of them, and it uses a volume, which is not a bind mount, but a shared volume, to make it easier for you to backup and export your database when you're running a MySQL instance. So once you have created the database for the first time, if you make changes to the Docker Compose like I've done, and you recreate the container, because the database is already pre-populated in the shared volume, then the container is not going to make changes to your existing database service. So this is a little bit tricky, but it's something that you need to remember. And I was hit by that just now. So if you look at your volumes, you will see that some of your containers have volumes attached to them, and the Docker database is one of them. So an option here would be to stop all your containers. And this problem happens because we've been doing like iterative configuration of our containers. But here you can stop your containers, you can remove them all. So these are also commands that are useful to know. When you remove your containers, you shouldn't be afraid, because containers are designed to be transient. So you should be able to remove them whenever you want, because you can just recreate them again by running Docker Compose up. So this is what I'm doing here. And because I did RM, the volumes for my Docker container have been purged. So all the previous database configuration for MariaDB has been deleted as well, which means that now my options defined with my environment variables should be taken into consideration. If I can type the password very secret. Okay, so you can see that I have access to the MySQL service and that I can use my video database, which is automatically created when I create my Docker instance. So that's good. We've just been connecting to MySQL locally on the database container itself. So now what we would like to do is to be able to connect to it from the web container. In order to make that work, we need to have a MySQL client. Here we don't have a MySQL client in that container. So we have a couple of options. This container happens to be running an Ubuntu version, so we can use apt update, and then we can do apt install MySQL client, for instance. Just for the sake of the experiment, I'm going to recreate an image with Dockerfile. Actually make sure that we are using we are going to have MySQL client installed and available for us all the time. So here we want to make that completely interactive. So I'm going to use -y to make sure that we don't have any confirmation dialogues. And I'm going to run docker compose up -d. So now I want you to pay attention to the stages of the build. You will see here that well, my docker compose is not rebuilding my image because the image already exists. So I need to specify the -build option. And here in my build, you will see that most of my build steps are actually cached. So here it says using cache, so it's not going to rerun all these commands again because they've already been run in a previous run. So it's just going to use cache. So that's also what I was talking about regarding Docker layers. Each command in your Dockerfile will create a new layer. And when you build your containers, only the layers who have changed will be rebuilt. It looks like my script or my run command is not really great because first of all, it says that apt does not have a stable CLI interface. So I should use it with caution. And it looks like my SQL client is not the name of the service that I want to, the package that I want to install. So let's investigate this. So I'm going to go apt get -q -y update. So that's fine. And now install MySQL client. That doesn't work. So maybe, well, let's do apt search MySQL. Probably default MySQL client then. I was not aware of that. Default MySQL client. Yeah, no sudo required because there is no sudo in a Docker container. Okay, so maybe it's default MySQL client. So let's move that to our Dockerfile and adjust our changes here. Apt get. It's called default MySQL client. And let's build the whole thing again. So I'm making sure that I update all my packages, and now I'm installing MySQL client. The build has completed, a new image was created, and a new Docker container running. That image should be now up and running. So I can now exec web bash. And inside my web container, I should now have a MySQL client. Now, the really good thing about this is that I can try to connect to my SQL server, but obviously I don't want to connect to a local MySQL service because this service is actually running on a separate container, on the database container. And this database container is the service DB in my Docker-compose file. So now I can use this DB host as my target to connect to MySQL. And now I'm on my database service running on my other Docker container. So this way this works because we use DB, and this DB matches the name of the service DB here, which was specified in my Docker-compose file. And it has nothing to do with the name of the container or even the name that you may see here. So never use these names because they change all the time. If you move your Docker-compose files to a different directory, these are going to change. So you don't want to use them. Use the name of the service as defined in the Docker-compose file. All right, so now we can connect from our Nginx to our database service. So we can actually do something like, let's see, I think minus should work. That's minus H. And we don't get the output back because we should use minus T because we want to create a pseudo terminal. Oh, it's minus T is capital T. Okay, well, maybe my MySQL command is not valid. I would need to double check that. But we can, we don't have tables, so that's why this is not working. That's why we don't see anything. It actually makes sense. There are no tables yet, but we can connect to the MySQL service from the different containers. So that's what we wanted to look at for now. So you have MySQL containers, you have Nginx containers, you can use Python containers, Node.js containers. Sometimes you even have application containers like the ELK stack. You can have containers about pretty much anything you can think of. And if such a container does not exist on the Docker Hub, then it's up to you to create your own container that customizes the way an existing container works. And the last thing that we want to look at now is that the way we built this Docker Compose environment is that there is no actual meaningful way of making sure that the database is the Docker database container is instantiated before the web container. So in our example here, it doesn't really matter because we are not going to do any MySQL queries from the Nginx container. But in a real life application, there are situations where you want to make sure that your database service is up and running before you try to connect to it from your front end or from your middleware. So this is where there are dependency management in Docker Compose. Which is managed by the depends on keyword. So when you use depends on, you can provide the name of a service, and the dependent service is going to start after the other service has been started. It doesn't mean that it's going to wait for the application to be up and running. So if our database container here takes 20 minutes to spin up, then Docker will just spin up the database container. And once it has been started, it will start the web container. It will not wait for the service to be actually available. So this is the same kind of problem that we had with Ansible and wait for connection. It's a very typical problem in infrastructure automation. There are all kinds of ways of making that happen. Typically in Docker, we use Dockerize or wait for it. And this is a script that is going to connect to the target database. And as soon as the database service is ready to answer requests, then it's going to exit. We're going to not to look at that for now. We will do that next week, but it's just important for you to understand that there are two situations at stake here. One is the order of the containers, and the other one is the dependency of the services. So here I just changed the order the containers are going to be started in. And by using depends on DB, I will make sure that my DB container is always running before I run my web container. So we don't see a huge change here. So I can just stop everything. I'm going to stop everything and remove my container using RM. And now if I up -D, you should see the database being created first, because that container is the dependency that the web container requires in order to run. Just show the Dockerfile, Docker-compose again.